Hello guys, welcome to H2O, the A to Z of chemistry. I am Dr. Ritu Johar, your educator for this course, General Organic Chemistry. So we will be beginning with this new course today, and this is called in short as GOC. This is a course for class 11 students who have opted for medical and non-medical streams, and they are preparing for the medical and engineering entrance examination. Well, this is a part of the NCERT chemistry curriculum for class 11th, and according to that, the topic that is in the NCERT textbook where you will be finding this course is some basic principles and techniques of organic chemistry. So principles we will be learning in this course on GOC, and the technique part we will be taking up in another course. This course is essentially a foundation course for the study of organic chemistry. So it is important not only for class 11 students but also for class 12 students. All the class 12 students who feel that the basics of organic they are not clear, well, this is a course which is going to be very helpful for you. Now, before we begin, I will be giving you a brief insight into what you will gain by subscribing to our courses. So the salient features of the course, please do not forward this portion of the lecture because this is going to be very important. I do not repeat these things in starting of every lecture. It is only at the start of a particular course that I tell you certain very important things. So please do not forward it and listen to the whole thing. So these are going to be the salient features of the course, and in our courses we try to provide you a thorough knowledge of the NCERT book text because we have a firm belief that the NCERT textbook is very important for you to excel either in your school examinations or for the competitive examination, and generally the students do not read the NCERT textbook. So we have tried our level best to provide you a thorough knowledge of the NCERT book text, but please, I would request you all that along with the lecture, what portion I am covering with you people, to read that much portion from the NCERT textbook along with. This will really help you excel in any examination. The next thing, there are certain topics that would require a higher level of study. So we will be providing you all the possible additional content for being a top ranker in any competitive exam. The next thing over here that we will be doing is that we will be discussing all the things at length with you people. The all presentations that you will be seeing, they are going to be PPTs, and there we are going to give you all the text as well as I would be explaining whole things. So this will help you prepare your notes, and when you are doing your revisions you will find that this is going to be sufficient enough for you to do your revision and then excel in your examinations. And there will be answers to tedious questions. We will be putting up competitive questions also wherever required, and we will be trying to help you as much as possible. And as far as your doubts are concerned, well, you can put that in the comment section. You can also post it on our email ID, which is given at the end of every lecture. The last slide has an email ID. You can also join us on a Facebook page, which is by the name of H2O Chemistry. So all that you can do. If you have any doubts, you can share your feelings with us. You can rate our lectures, review our lectures. Do share it with your friends if you like the lectures. And one important thing before leaving, please do click on the like link if you're liking the lectures, and also do subscribe to the channel. Otherwise, you're going to miss many important things which we are providing for you people. So having said this, we will be starting with lecture 1 from the course General Organic Chemistry, where you will be learning what is basically the meaning of organic chemistry. So I will be giving you a brief introduction to organic chemistry. Then we will study why there is a need for a separate study of organic compounds. Then importance of organic compounds and tetravalency and shape of carbon compounds. So we will be beginning with the introduction to organic chemistry. So to begin with, let us understand first of all what is organic chemistry, and for that let us begin back with chemistry only. So chemistry, this is a branch of science which deals with the study of the composition of matter and the chemical changes involved with it.
So we are understanding what is matter, what are the constituents of matter, well, the states of matter, the solid, liquid, gases, how they are interacting with each other, and due to the interaction, what all is produced. That all we study in chemistry. And as far as the branches of chemistry are concerned, we are going to broadly classify chemistry into three branches: physical chemistry, inorganic chemistry, and then organic chemistry, which we are going to start studying in this course. So physical chemistry, this deals with the fundamental principles underlying the various chemical phenomena, right? So how the states of matter, for example, the gases, they are going to interact with each other, how the gas is going to interact with the liquid, or how a gas is going to interact with the solid. So forth, all these discussions, they are a part of physical chemistry. Then we move on to inorganic chemistry. So this deals with the study of all the elements and their compounds except the covalently bonded compounds of carbon. So all the elements 118 we study in inorganic chemistry, and for carbon, what we will be studying in inorganic chemistry is going to be, for example, the oxides of carbon like carbon dioxide, carbon monoxide. But the covalently bonded compounds of carbon are ones which we study in the branch organic chemistry. So essentially, it is going to be the study of carbon and its compounds. Now, giving you a brief history of organic chemistry. Well, organic chemistry history dates back to around 200 years back in the year around 1780s, when the chemists, they started distinguishing between the compounds they were obtaining from plants and animals being different from the compounds they were obtaining from mineral sources. So they called the compounds they were obtaining from plants and animals to be organic compounds, meaning that they were obtained from the organs of plants and animals, whereas those they were obtaining from mineral sources, they called them as inorganic compounds, which were not organic in nature. But it was in the year 1815 when a Swedish chemist, Berzelius, he proposed vital force theory, according to which the organic compounds, they are produced only under the influence of some mysterious force existing in the living organisms. So they understood that organic compounds, they can be only obtained from the living organisms, the parts of living organism, but they could not be synthesized chemically in the laboratories. So Berzelius, he was the one who gave the term organic chemistry a definition. So according to which organic chemistry, this is the branch of chemistry that deals with the study of organic compounds. And what are organic compounds? Well, they are the compounds which are going to be derived from living organisms only, both plants and animals. For example, DNA, proteins, carbohydrates, fat, vitamins, they all are organic compounds. Now this is till Berzelius, and after some time later also, this definition continued. It had its significance because we could obtain organic compounds only from plants and animals. But then it was in the year 1823 when a scientific mind, Friedrich Wöhler, joined Berzelius as his student. And it was in the year 1828 he proved his teacher wrong. And how did he prove him wrong? Well, he synthesized urea, a component of urine, so which is derived from the animal sources. So urea he synthesized in the year 1828 from ammonium cyanate, which is an inorganic compound. So he just proved the definition given by Berzelius wrong, that the organic compounds, they cannot be synthesized in the laboratory. Right? So let us see the reaction for that. The reaction is that NH4CNO, which is ammonium cyanate, when it is heated, it gives us urea NH2CONH2. So we can synthesize organic compounds from inorganic compounds as well. And then this revolutionized the whole thought of organic chemistry. The people, the scientists, they started synthesizing more organic compounds, and we saw many compounds coming up. For example, Hermann Kolbe, in the year 1845, he synthesized acetic acid CH3COH, and M. Berthelot, he synthesized methane CH4 in the year 1856 from inorganic sources. And then further, more and more organic compounds, they started being synthesized, and we have now millions of organic compounds. Now the definition of organic chemistry, this also had to be changed because we can get them from inorganic sources as well. So now what we have Organic chemistry definition is that organic chemistry is uh, dealing with the study of the compounds of carbon, or you can say it is dealing with the study of carbon and hydrogen and their derivatives. So it is essentially hydrocarbons and their derivatives which we are studying in organic chemistry, because as you can see, urea over here, this consists of carbon and hydrogen. Acetic acid, you can see again we have carbon and hydrogen. We have methane, again carbon and hydrogen. So essentially in most of the compounds you will be seeing carbon and hydrogen in the compound, and there are going to be other elements along with that. Sometimes you will be seeing that hydrogen is missing, but they would be essentially the derivatives of hydrocarbons that we will be studying in organic chemistry. Now let us understand why there is a need for separate study of organic compounds, or we have a complete one branch devoted to just one element, carbon and its compounds, when all the 118 elements and their compounds, they are placed in one branch of inorganic chemistry. So even in that 118 elements, we have some compounds of carbon like carbon monoxide, carbon dioxide and so on. So we have one branch for 118 elements and their compounds, and one branch for just one element and its compounds. Why is it so? Let us understand. There are going to be two reasons for this. One is that the number of organic compounds is very large as compared to the number of organic compounds. If you see over here, the number of organic compounds, this is 6 million, whereas inorganic, they are just being around 90,000 compounds. So this is bigger difference to justify the reason that there is a separate branch for the study of organic compounds. Then why is this large number for the organic compounds? Well, the number is large because of a unique property for carbon, that is catenation, which means essentially that the carbon atom, this can combine with other carbon atoms in long chains, and therefore we have a large number of organic compounds. We will be studying more about all these points once again in the next lecture in today, just giving you a brief introduction here. Then we have isomerism, a phenomenon which is seen over here, where one molecular formula represents multiple compounds having different properties, and again this is going to be responsible for a large number of organic compounds. Then carbon, this can form multiple bonds, a single bond, a double bond, a triple bond, so as to satisfy its tetravalency. Therefore we will be having again a large number of compounds. The electronegativity of carbon, this is neither very low nor very high. This is 2.5, and the size of carbon, this is very small. Therefore carbon, this can form strong covalent bonds with hydrogen, oxygen, nitrogen and other carbon atoms, and this also adds to the number of carbon compounds. So now one reason is that the number of organic compounds, this is large, and the other reason is the properties of organic compounds, they are very different from the inorganic compounds. For example, the structures of organic compounds, they are very complex, whereas the structures for the inorganic compounds, they are relatively simple structures. If you consider the composition, well, the organic compounds, they consist of very few constituent elements like carbon, hydrogen, oxygen, nitrogen, sulfur and halogens, whereas the inorganic compounds, they contain almost all the known elements. Considering the bonding, well, most of the time we will be seeing covalently bonded compounds in case of the organic, whereas in the case of inorganic we will be seeing more of ionic bonding. Next we have is the solubility. So the organic compounds, they are more soluble in nonpolar solvents, whereas the ionic compounds or the inorganic compounds, well, they are going to be more soluble in the polar solvents. The melting and the boiling points, they are low in case of organic, whereas they are going to be high in case of inorganic compounds. If you consider the nature of the organic reactions, well, organic reactions, they are generally quite complex. They take place under specific conditions. They are quite slow, and sometimes they even do not proceed to completion. So the reactions involving inorganic compounds, in fact, they are going to be very fast and they take place under ordinary conditions. If you consider the combustibility, well, organic compounds, they are generally going to be combustible. Inorganic, they are going to be generally non-combustible. Now, if we consider how are we going to do the analysis of these compounds, so the technique of analysis is quite different class in itself. For example, the analytical techniques like steam distillation, solvent extraction, chromatography. These all techniques, they are quite special techniques, and we generally do not use them in the case of inorganic compounds. If we consider the conductivity of these compounds, they are going to be much lower than the inorganic compounds. And as far as stability of these compounds are concerned, they are usually less stable to heat than the inorganic compounds. Now, these all differences and a large number of compounds make the study of organic compounds needing a completely different branch, a special branch which we call as organic chemistry. So I hope this is clear to you.
So now let us understand what is the importance of organic compounds, or we can say what is the importance of study of organic chemistry. Well, if I put forward this question in front of you, that why are you going to study organic chemistry? Well, I know your answer for sure. The answer is going to be that, ma'am, we are going to study organic chemistry because this is a part of our curriculum, and if we do not study it, well, we are not going to get good marks. Well, you people are right that you have to study about all this that we are going to study in this course because you have to get good marks. But then there are other reasons as well why you should study organic chemistry. You should study organic chemistry because we have organic compounds everywhere around us. Be it your pen, be it your book, be it the laptop or the phone which is in front of you, be it the television, be it the plastics that we are using, and so many other things. Everything is going to be organic compound. And then you people as budding scientists, engineers and doctors, you should have a thorough knowledge about these organic compounds. Let us quickly see a few examples where these organic compounds are so much important for all of us. The first importance is going to be the food. So we all have now studied that initially only from about 200 years back also we know that the organic compounds, they were derived from plants and animals, and we get our food from plants and animals. So with food without which we cannot live, we cannot even imagine living. So these are organic compounds and we should have a knowledge about them. The fertilizers that we give to our plants so that they grow well, they give us good food, then again they are going to be derived from organic compounds. The clothes that we wear, well, they may be from natural sources, they may be from synthetic sources. For example, cotton, silk, and rayon, nylon, everything, whatever we are wearing, they are going to be organic compounds. The medicines, they are going to be derived from organic compounds. For example, the simplest medicine that we give for fever, that even a layman knows, that we give a paracetamol when we have fever. Well, that is nothing but an organic compound. The plastics, they are everywhere around us, and in fact they have become such a big nuisance that we even have a drive going on that these days for the ban of the single-use plastic. So you can understand these plastics which have become so much a part of us, and they are creating an environmental disturbance so much. They are all organic compounds, and without their knowledge, well, you as science students are going to be misfit. Then the petrochemicals that we are using, all the petrol, the diesel, the cars and the scooters, we are running all of them. So these are nothing but organic compounds. Quickly telling you a few more, I hope you have now understood that the organic compounds are quite important for us. So many industrial products, cosmetics, dyes, explosive, insecticides, pesticides, disinfectants, all are organic compounds. So apart from scoring good marks, being good citizens, being good science students of the nation, it is very important for you to study about organic compounds. And now let us begin with actual study. We now know that organic compounds, they are going to consist of carbon and hydrogen as essential constituents of all compounds. They are called as hydrocarbons. So hydro for hydrogen and carbon for carbon, obviously. And we are going to have organic chemistry to be the study of hydrocarbons and their derivatives. And it was shown by Lavoisier in the year 1774 that all organic compounds, they have essential constituents carbon and hydrogen, and it is because of the virtue of these that they are showing similar properties. And out of these two, carbon and hydrogen, we have the property of catenation for carbon. It is a unique property of carbon that carbon is making long chains, whether straight or branched, which we will be seeing in the further lectures, that it is making by the use of covalent bonding with hydrogen, nitrogen, oxygen, sulfur, even with itself also. So many carbon atoms, they are joining in long chains, and that is because we have a large number of organic compounds. So out of the two, carbon and hydrogen, it is carbon which is more important to us study, and we will be studying just briefly about that, what all we have discussed earlier in periodic table courses and chemical bonding courses that we have already studied. We will be summing up all that information because carbon is going to be very important for our study. So carbon is tetravalent and it shows covalent bonding, and this is because of the virtue of its electronic configuration and hybridization of the carbon atom. So hybridization we will be discussing in the next lecture. We will be just revising the concepts that we've already learned while we were doing the course on chemical bonding. The complete course on chemical bonding, this has detailed lectures on hybridization. If you've not watched those, please do watch them to clear your concepts. Each and every concept of hybridization I have taught in great detail. Okay, now as I was telling you, so a carbon atom, this is showing hybridization, and it is by the virtue of its electronic configuration that it is tetravalent in nature. So let us just quickly revise those concepts over here. So carbon in its ground state, it has an electronic configuration of 1s2, 2s2, 2px1, 2py1. So according to the concept of covalency, covalency of an element, this is going to be equal to the number of partially filled orbitals, right? And here we are just seeing two partially filled orbitals. According to this, carbon should be divalent and not tetravalent. But then we understood that in the carbon, in the excited state, it can move one electron from the 2s orbital to the 2pz vacant orbital, and then there are going to be four orbitals which are going to be half filled, and these four orbitals are the ones which are going to participate in bond formation with other atoms, and these are going to be responsible for the tetravalent compounds carbon shows, for example CH4, CCl4, etc. Right? So this is what we mean, that carbon is tetravalent. It can form four bonds, and this four bonds it forms by the sharing of the electrons, and therefore it shows covalent bonding. Now remember one thing over here, that the energy which is released due to the formation of two more bonds by such carbon in the excited state, this more than compensates for the energy required for the excitation of electron. So that is why it is more favorable for carbon in the excited state to form these four bonds rather than just having two in the case of the ground state configuration. Moreover, when it is going to have form just two bonds, its octet is not going to be complete. Here with the four electrons unpaired, we can form four bonds, so it can complete its octet, and that is one of the reasons we have studied in the octet rule, that it is going to participate in bond formation. So as I was telling you, we will be discussing about hybridization and bonding of carbon in the next lecture. And so please do subscribe to the channel H2O. Also do click on the bell icon so that you get a notification the moment we put up the next lecture for you, because each and every lecture is going to be very important for your understanding of GOC, and the whole understanding of GOC is going to be very important for your understanding organic chemistry. The moment you miss one lecture, you are not going to understand many concepts related to organic. And in fact, as I was telling you in the start of the course also, that organic chemistry is going to form a major portion of your examinations, as you will be seeing the previous year papers as well. So you should not miss a single lecture. This is going to be really very important for you. Your whole concepts are going to be covered in 11, and then when you move on to class 12, we will be just building up on our knowledge. So please do subscribe to the channel, click on the bell icon. If you have any doubts, feel free, mail us at h2ochemistry@gmail.com. You can put your doubts in the comment section also. You can join us on Facebook by the same name, H2O Chemistry. Well, we revert back within 24 to 48 hours. If you have any doubts, feel free, not keep your doubts to yourself. We believe in the motto that you should excel. We are providing you education so that you can excel in your examinations. You become the top rankers. You have a brilliant future. So please do not keep your doubts to yourself. Okay, so that is what we would say again and again. Any doubts, most welcome at H2O Chemistry @gmail.com. See you again. Have a nice day. God bless you.